Differential equations, we're in the 4.1 through 4.3 review. We are on our final problem, although there are three parts to it, three distinct problems. So this is the most recent material, and I hope that actually is going to speed some things up for us. Take a look at this. We've got all constant coefficients, which is lovely, which is wonderful. It is an initial value problem. And let's see what we can do here. It says, solve each for the IVP, find a general solution if it's a non-initial value problem. Let's see what that means. We're going to assume that y equals e to the mx is a solution. That's a very reasonable kind of an assumption that we can make. When that is true, this will become m squared minus 10m plus 25 equals 0. This will factor into m minus 5 times m minus 5, meaning we have what's known as a double root. What we have here will be a solution of e to the 5x, but because we have this double root, remember we're going to have x times e to the 5x. And now normally we would look at this and say, well, this is fantastic. It looks like we're done. It's just that now we're going to have to find out what these constants are. This is where the initial value comes into play. So you may certainly take a first derivative here because you're going to need to. Let's look at that. As you take your first derivative, we're going to need the chain rule, aren't we? That's going to be 5 times c1 e to the 5x. And then, with our c2 here, of course, we're going to need the product rule. As we take the derivative of our uv here, we'll have x times e to the 5x's derivative. So a 5 is going to come out. And then we can say plus, well, the derivative of x is just a 1. And we'll have that as e to the 5x. Well, here we have y prime of 0 equals negative 1. We also have over here y of 0 is equal to a 2. Well, what does that really mean? Well, it means this, that, when x is equal to 0, y is equal to 2. And we could go ahead and begin to work that out. This is e to the 5 times 0, which is just a 1. Here, though, very nicely, take a look at this. This just completely wipes out. And without too much work here, we already will know that, 5 times 0 is a 0. E to the 0 is just a 1. We are really lucking out in this regard. We know at this point that C1 is actually going to equal 2. We've got one of our two constants. To find the other one, of course, we're going to have to come over here. And this is saying that when x is equal to 0, y prime is equal to negative 1. So what we've got is this e to the 5 times 0 right here. We've got c2, which is 5 times 0 e to the, well, we know 5 times 0 is a 0. That's going to wipe out. Here we've got to be so careful. I think you can see what I'm getting at. But you can pretty quickly see how close we are to finishing this up. E to the 0, of course, is just a 1. E to the 0 right here is a 1, but multiplying by 0 makes that completely go away. And this is e to the 0 right here, which is a 1. So it's 1 times 1 is just a 1. 1 times c2, we've got our c2. But realize that our c1 is actually the number 2. So 5 times 2 is a 10. And without too much work, you can see that C2 is negative 11. Well, please understand that ultimately your answer must be, your C1 is a 2, so you'd have 2e to the 5x. Your C2 is actually a minus 11. So the particular function that satisfies that differential equation and that also satisfies the initial conditions would be what we have here boxed. Y equals 2e to the 5x minus 11x times e to the 5x. Could even factor out an e to the 5x out in front if you'd like. Well, again, how do we go about with b? Well, we're going to assume that y equals e to the mx is a solution. That's going to leave us with m squared plus 2m plus 2 is equal to 0. Now, I think it's here where we might get a little uncomfortable. You could try to factor that, and it will not factor. What you can do very quickly, you could either solve this with your TI-89, which is okay. You could definitely do that. I definitely don't want you, however, to forget one of the most important formulas in all of mathematics, and that's the quadratic formula. And it only takes a moment for us to work through that. We'd get negative 2 plus or minus, well, a 2 squared is a 4. Then we'd have 4 times 1 times a 2, and down below it's 2 times 1. And let's see where we're going with this. Well, we'd get negative 2 plus or minus. Well, 4 times 1 times 2, that's an 8. 4 minus 8 is actually a negative 4. And I think it won't take you too long to see that the square root of negative 4 is actually a 2i. And that is going to leave us with negative 1 plus or minus a 1i. What we really know is that alpha is equal to negative 1 and beta is equal to a positive 1. We have complex solutions. And when you have complex solutions, I hope you remember that your general form was e to the alpha x, and then we had a constant, cosine of beta x, plus C2 sine of beta x. Well, it's only going to take you one little moment to plug that in. And negative 1x is just e to the negative x. You've got your C1 here, but it's the cosine of a 1x, which is just an x. Got your C2 here, the sine of 1x. You could just write it as the sine of x. And there you go. This is the most general solution that you're going to find. This is going a lot quicker than some of those earlier ones, right? So one last one as we're looking through this. Wow, you know what? We're going to have a little bit of a problem here, aren't we? We're going to have to fix this up. I think I forgot to eliminate one of those. We've got y of 0 is 0. We've got this y of 0 equals 5. That should be deleted. That should not be present, right? So let's go ahead and just work this thing out real fast. We've got m squared minus a 2m plus 1 is equal to 0. This would be an m minus 1 times an m minus 1. And, of course, you've got m equals 1 and m equals 1. What's our general solution going to be? Well, we're going to have an e to the 1x. Could have that there. But for our second solution, that's going to be x e to the 1x. So it's at this point where, my goodness, here we go again. We can really pull together a few things here. It's very much like our first answer for part A. As we've got this thing going, we can pretty much take a derivative y prime is going to be, well, derivative of e to the x, no chain rule there. Let's just keep our c2 out in front. That's x times, well, the derivative of e to the x is just e to the x. With the product rule, the derivative of x itself is just a 1, if you'd like. And we've got our y prime of 0 is equal to 10. That means x equals 0, y prime is equal to 10. Here we had y is equal to 0 when x is equal to 0, right? So let's go ahead and see what we've got. This is e to the 0 right here. And here's c2 times 0, e to the 1 times a 0 also. Anything times 0 goes away. And then e to the 0 is just a 1. I deliberately wanted to focus in on this initial condition because it can upset kids a lot. I think you're going to see why in just a moment. What gets kids upset is they're going to say, well, if C1 is 0, part of your answer is going to disappear. And that's true. We'll get to that in just a moment. We'll talk about that in a little bit more. But that's why I immediately crossed out the second initial condition. That I made a mistake putting this problem together. We'll fix that up. But look, all we've got to do here is plug in our y prime of 10. Once again, we've got our e to the 0 right here. Look at that. Here's 0 times e to the 0 plus 1 times e to the 0. Well, 0 times anything completely goes away. E to the 0 is a 1. Here's just a c2. But c1 is 0. That means c2 is equal to 10. Well, here is your particular answer. And this is what I'm talking about. So very often when kids get to a point like this, they'll wonder, wait a minute, is this really okay? Is this all right? That one family of solutions, namely that e to the x, was canceled out by your constant. And definitely, what we're seeing is you could get any linear combination of those answers, your C1 and your C2. So just wanted definitely to point that out to you to make sure you're aware of it. Hope this is going well. This is not our only review. We're going to have another one next week, and I'm hoping that that's going to help you out a lot.